All right, going along with our previous video talking about the most common ion and using our knowledge that we have of ionization energy, we know that elements that are on the left-hand side, so elements that are over here on this side of the periodic table, lose electrons very easily. And as you go down down the periodic table, you also lose electrons more easily. So the atoms that lose electrons the easiest on the whole periodic table are down that bottom left-hand corner. Okay, so when those group 1 or group 2, so this is our group 1, group 2 metals, and they lose electrons to form a positive ion, the reason that it happens so easy is because they have a very, very low ionization energy. A lot of times we say it that the elements, the farther you go left, the more metallic character that element has. So the elements on the very far left-hand side of the periodic table have more metallic character than the elements on the right-hand side of the periodic table. And they define metallic character by how easily an atom loses electrons. So we know that elements on the left-hand side have a low ionization energy. We also know that as you go down a group, the ionization energy goes down. So therefore, we know that it's reasonable to assume that when going to the left and going down a group, the reactivity would increase, which means things become more reactive. Okay, so for example, starting with the alkali metals, you've got hydrogen at the top, which is not a metal at all, but then you've got lithium, and then you've got sodium, then you've got potassium, and then you keep going from there to rubidium and cesium. Okay, and you've probably seen, if not, you can look it up on YouTube, lithium, sodium, potassium when you put them in water. Lithium will they all will react pretty vigorously with water, but potassium reacts the fastest and the most vigorously, you would say, whereas lithium would react the slowest because, again, as you go down that periodic table, the ionization energy goes down. So you're getting these electrons here in that potassium are held less strongly as in lithium. Okay, and again, we can assume that the group 1 metals are more reactive than group 2 because, again, they have lower ionization energies. Okay, now some common reactions that happen between metals in the first and the second group. So again, the first and the second group, we're talking about, let me draw another periodic table here. So group 1 and group 2, we're talking about, this is group 1, sometimes they put an A, and that's group 2. So group 1A and group 2A, obviously excluding hydrogen because it's not a metal. Okay, so any element, any metal that's in this first column or second column will react in the same way. And that one of, if it's a group A metal, whether this is lithium, like I just showed you, sodium, potassium, it reacts with water. It does release a large amount of energy. And when it does that, you see it might light on fire, it might explode. There's lots of possibilities there. Okay, and the type of reaction that happens here, a lot of times with water, I like to write it as HOH, and then I think of HOH as H plus and OH minus. Okay, even though it's not really that, it helps in a case like this because you're going to have a group 1 metal that can have a positive charge, and so what happens is this positive here is going to come in and kick out that positive there. And see what happens here is now you have MOH on the product side, MOH, and when hydrogen's by itself, you've kicked the hydrogen out. There's always 2 of them, so it's a diatomic molecule, so you've got H2. So anytime one of those metals, whether it's a group 1A or group 2A metal, anytime you put them into water, they are going to produce a metal hydroxide. OH is a hydroxide. And hydrogen gas. Okay, a metal hydroxide, many times we refer to that as what's called a base, and we're going to learn plenty more about bases later on this year. Okay, so a metal plus water makes a base, a metal hydroxide, and hydrogen gas. Okay, So that's one type of reaction that happens. So a metal, a group 1A or 2A metal by itself reacts with water to make MOH or MOH2. Why the OH in parentheses and the 2 here? Because again, if it's in group 2A, what's its most common ion is M2+. So when you put M2+ with OH minus, that 2 has to come down here, so you're going to get MOH2. Okay, now another type of reaction that happens is not a metal, but in this case it is a metal oxide. So whether it's like in this case sodium oxide, lithium oxide, potassium oxide, anytime that happens, you also form a base. Now notice it's a different type of reaction up here. Up here you had an element by itself, and it's replacing another element, okay? If you remember, that is referred to as a single replacement reaction. Again, don't need to remember that, but it's just, oh, that's a single replacement, where one thing is by itself and it replaces one other thing, that's a single replacement. Okay, in this case, we're taking two things and we're combining them together to form one thing, okay? And that is referred to as a synthesis reaction. When you synthesize something, you make it. So we're taking two things and combining them together to make one. So, again, a metal by itself reacting with water up here produces a base and hydrogen in a single replacement reaction. A metal oxide and water also produces the base, but that's it, just the base. Okay? So there's a big difference between a metal and water and a metal, notice the oxygen here, a metal oxide in water. A metal oxide in water produces a synthesis reaction, so it combines those two together to produce a base. Okay, and then really the last one here also, as you can see, it is a synthesis reaction. But notice the difference here. This is a nonmetal. Sulfur is a nonmetal. A nonmetal oxide, when you react that with water, what do you get? So here you got the base, the hydroxide. You always get OH. In this case, you get an acid. H2SO3 is sulfurous acid. So in both cases, it's a synthesis reaction. Whether it's a metal oxide or a non-metal oxide, they're both synthesis reactions. But when that happens, one of them produces a base, and a base is something that has hydroxide in it. And the other one produces an acid, something that starts with hydrogen, like we learned in Unit 0. Okay, and that is it for today.